2A, we're going to look at principles of experimental design. So some of this stuff may be familiar to you from like science classes or if you take an AP Psych, but the vocabulary might be slightly different. So just make sure you pay really close attention. Okay. To talk about all of this stuff, we're going to use this experiment as an example. So I want you to pause and read about this experiment. Okay, so the parts of the experiment that you will need to be able to identify. First is factor. This can also be referred to as an explanatory, or the more common term that you've probably heard is independent variable. That is, what is the experimenter manipulating? What are they changing? So in our corn example, that would be the fertilizer. And then the dependent variable, which can also be called the response variable, that's what are we measuring to see if the treatment was a success. So what are we measuring to see if our fertilizer worked? And they're going to count the number of sellable ears of corn. Level. This is the way that our factor or independent variable can be applied in different ways or degrees. Not every experiment will have different levels. So in this experiment, the new fertilizer is going to be at 25% concentration and 50% concentration. Those are levels because it's the same factor, it's the same fertilizer, but it's at different levels. Okay, that's more common in like medication trials where we try like different dosages of medicines. Does not exist in every single experiment. All right. Treatment is the different combinations of factors and levels. Okay, this is where we get very specific. What exactly are the subjects being given? So what exactly is being given to this corn? The options are no fertilizer, old fertilizer, the new fertilizer at 25%, and the new fertilizer at 50%. Okay, so treatment is where we get very specific about what exactly are we giving. And then experimental units, aka subjects, okay? So the person, place, or thing, it's got to be a noun, that is receiving a treatment, okay? So in our corn example, that would be the 12 plots. That is what is getting the different kinds of fertilizer. All right, some other vocab that we need to know. A control group is a group that is given no treatment or a placebo treatment. So like in our corn example, that would be all of the plots that got no fertilizer. So a control group gives us like a baseline to compare things to. Placebo is a fake treatment, okay? It's harmless. It's usually like a sugar pill or something like that. It doesn't have any medicine, but it looks like the real treatment. And the reason we give placebos is because of something called the placebo effect, which is where people may react favorably to being given something, even if it's not a real treatment. Okay, so think about when you were a little kid, you fell down and you asked your mom to kiss your boo-boo, right? And all of a sudden you felt better. Is there anything really medically effective about her kiss? No, but she gave you something to make you feel better. So we give placebos so that we can tell, is there a difference just because we gave you something, or did the real medicine work better than the placebo? All right, and then confounding variables. That's anything other than the treatment that might have an effect on our dependent variable. Okay, so for example, men and women may respond differently to medication. Okay, so in this case, gender would be a confounding variable. So when we design experiments, we want three things. We want control, randomization, and replication. Okay, control is keeping things other than the treatment as similar as possible to limit confounding. Don't confuse control here with control group. Okay, control group is to give us a baseline with no treatment to compare to. Control in an experiment means trying to keep as many things the same so that the difference can be totally attributed to our treatment. So in our corn example, each plot got the same amount of water, the same amount of pest control, and the same amount of sunlight because the plots were all in the same field. Okay, those things are control because if we gave them different amounts of water, did more corn grow because of the water or because of the fertilizer? We wouldn't know. So we try to keep all of those things the same. Okay, randomization. We want to randomly assign things to our different treatment groups so that there's no bias in the way we are assigning things. And then replication means having multiple subjects receive the same treatment. Okay, so we had 4 treatments in our corn example. And so they didn't just pick 4 plots, they picked 12 plots so that there were 3 different plots that all got the same treatment. That way we have multiple times of trying this treatment to see how it works. There's different ways that you can design experiments to get those 3 things. We're going to talk about 3 of them: completely random, randomized block, and match pairs. Okay, so completely random is exactly what it sounds like. All of the subjects are put together. We usually number them and use a random number generator to randomly assign them to our different treatment groups. Okay, this is the simplest, the most convenient, but we can't control for differences in our subjects. So let's say like we had, our subject group had more females than males. If we did completely randomized, we're probably going to end up with certain treatments that have more females than males, and that could potentially be a confounding issue. So completely randomized, we typically use for experiments where we have a large group of subjects, because when we have a larger group, all those things tend to even out. Okay. Randomized block, all right, that is how we address that issue. We divide our subjects into blocks by age, gender, or some other characteristic that we think might be a confounding variable, right? And then within each block, subjects are randomly assigned to a treatment. So let's say I'm testing a medication that I feel might work differently on men and women. I would separate my subjects first by gender, and then in the female group, I would randomly assign people to both treatments. And then in the male group, I would randomly assign people to both treatments. That way I can compare males to males and females to females and don't have to worry about that as a confounding variable. And then our last option is something called match pairs. There's 2 different ways that match pairs can be done. One is we take subjects who are similar to each other and we pair them together. So a lot of times this is done with identical twins. So if I get a pair of identical twins, I give one twin treatment A and the other twin treatment B, and then I compare them to each other. Because they are so similar, that way that's an element of control because their DNA is exactly the same. So all of those things are going to be the same, and that way I can see if my treatment is making a difference. Another way to do match pairs is where each subject receives both treatments, but you have to make sure that you randomize the order of the treatments. So let's say that, I had a pair of shoes that I said, these shoes make you run faster, right? If I just had some people run with shoes and some people run with like their own shoes, people don't all run the same speed. So did the people run faster because of the shoes or just because they're just faster runners? We don't really know. So if I have you run with my shoes and then you run with your shoes, then I can compare you to you and see which pair of shoes made you run faster. Okay. And so we just do the random part is, are you going to run with the new shoes first or your shoes? Okay. So that's it for experiments.